All right, so today we're going to talk about function notation. So I just want to remind you that a function is a rule that assigns one input to one output. So this is what function notation looks like. So it looks like an equation. So typically here we would usually use a y, but in function notation we replace this with this f and the x in parentheses. So this does not mean f times x. Okay, this is not multiplication. Okay, so it's not multiplying, it's not f times x. All right, this is what replaces y. This is our output. And it is read as f of x. So when you see this, you say f of x. Sometimes you will see a G instead of an F and you would read G of X or H of X. Okay, so when it's in function notation, it's not multiplying, it is read as F of X. Okay, so the other way that we could write this would be y equals 3x plus 4. Okay, so the y was just replaced with this f of x to make it a function, or to make it in function notation. So what this is f tells us the name of the function. The f tells us the name of the function. So we would say, oh, this is function f. And then we all know that x is our input. It's the independent variable. That is input into the rule. Which leads us over here this whole thing is the rule. It's what we use to get our output. Okay, so that's function notation. So this is how function notation works. So what they'll do is they will give you here something like f of 2. So what this is telling me is that I'm going to replace x with 2 in my function. So I'm going to input 2. So f of 2 is my input into the rule. So 3 times x plus 4. So x is being replaced with 2. So 3 times 2 plus 4. So 3 times 2 is 6 plus 4 is 10. So that means that my output is 10. So we would say that f of 2 equals 10. So then this one is f of negative 1. So what that means is that I'm going to input negative 1 into my rule. So it was 3 times x, which is now negative 1. And then I get out. So 3 times negative 1 is negative 3, plus 4 is 1. So that means that f of negative 1 equals 1. So when I input 1, my output is 1. So let's take a look at the inside, which is upside down. Sorry. All right, so we're going to take a look at some examples here. So our first example, f of x equals x squared minus 3x. So if I'm going to do f of 5, that means that I need to put 5 in for x squared, or for x. Oops, 3 times 5. So I replaced x with 5, so I have to do 5 squared minus 3 times 5. So 5 squared is 25, 3 times 5 is 15, and then 25 minus 15 is 10, so f of 5 equals 10. So now we're going to take a look at a different example. So f of 3. So I'm going to input 3 into this new equation here. So negative 3 times 3 is negative 9, plus 1 is negative 8. So f of 3, when I input 3, my output is negative 8. So this one here, they're not asking us to input a number on this last one. They're asking us to input x plus 1. So in my equation here, I'm going to replace x with x plus 1, like this. So that means I have to distribute this 2. And then combine my like terms here. And 2 minus 5 is negative 3. So when I input x plus 1, my output is 2x minus 3. That's A. So we're going to just add one more example here. So using this same equation, okay, we're going to figure out what x equals if f of x equals 1. So what that means is my output is 1. So I'm going to replace f of x with 1 and solve to figure out what x is supposed to be to get an output of 1. So I would add 5 to both sides and get 6 equals 2x. Divide by 2, and I get that x is 3. Okay, so that is how function notation works. And tomorrow in class, we'll talk about this side as a class, and then you'll do some practice.